Hi fellow colleagues and partners of DISCO. My name is Alan Sadimi and I'm from Lindholmen Science Park. Today I'm giving a presentation within the e-course to introduce DISCO Evaluation Dashboard, a critical tool developed to collect, analyze, visualize data presented by the Living Labs. The following presentation will give you a complete knowledge of how the dashboard can be used and what the tool is for. To understand the functionality of the DISCO dashboard, let's first consider the broader context of a typical project evaluation process. This process generally unfolds through 5 distinct phases: define evaluation setup and goals, develop evaluation concept, collecting, analyzing and evaluating, document and communicate, and optimize measures. The DISCO dashboard is positioned within the framework, specifically focusing on phase 3, collecting, analyzing and evaluating data. In the previous session, we mentioned that the dashboard supports all phases in the evaluation methodology. It can support the definition of the evaluation setup and goals, or for example serve as a tool for optimizing measures. However, the dashboard really comes into its own in phase 3. In this session, we want to show you how. The dashboard is designed to manage both input data and output data. The evaluation itself is fundamentally based on key performance indicators, also known as KPIs, which can be categorized, linked to specific Living Labs, and visualized effectively through the dashboard. Delving deeper into its purpose, the DISCO dashboard serves several critical functions that empower robust evaluation. It facilitates the collection and supply of data in a uniform way, ensuring consistency and comparability across different sources and Living Labs. It enables the association and clustering of indicators regarding relevant categories, providing a structured approach to understanding interdependencies and impacts. It is instrumental in processing and analyzing data from the Living Labs, transforming raw data into actionable insights. Crucially, it supports the visualization of indicator changes and the impact of the implemented measures, making complex data understandable and allowing for clear demonstration of progress in areas needing improvement. Let's take a closer look at the architecture of the evaluation dashboard. From a data processing perspective, the dashboard is intuitively divided into 2 primary areas: input and output. Important to note is that the data is still under review and may change in the future. On the input side, we find the baseline data and the KPIs. These provide direct shortcuts and hyperlinks to the foundational data collected from each of our participating Living Labs. These include Thessaloniki, Helsinki, Ghent, and Copenhagen. The input data becomes the output data shown in the dashboard as evaluation based on KPIs, KPI categorization, Living Labs, and dashboard visualization. It's important to note that the dashboard's flexibility allows for different evaluation approaches and results visualizations, adaptable to the specific data availability within each Living Lab. To facilitate robust analysis, evaluation, and visualization of results, the dashboard employs a sophisticated system of linking, clustering approaches, and categorizations. These essential categorizations are fundamental to organizing and interpreting the collected data. With main focus on the DISCO X measures, these are specific measures implemented within DISCO projects. Secondly, also focusing on the following categories for evaluation: the 7 Sustainable Development Goals. The dashboard aligns its analysis with specific SDGs, particularly goals 3, 8, 9, 11, 12, 13, and 17. There's also the 5 impact domains of DISCO, the SETR dimensions, which are the societal, economic, technical, and regulatory aspects, and the dimensions of energy efficiency gains. These measures can be categorized, among other measures, with the usage of pivot tables in the dashboard. The content of the pivot tables can be filtered based on desired preferences. A user may also create their own pivot tables from the collected data. Let's ground this with a concrete example of baseline data collection, using the Helsinki Living Lab as our illustration. The dashboard gathers baseline data, capturing conditions both before and after the implementation of specific measures. Consider the following changes observed in Helsinki between 2024, before the implementation, and 2025, after the implementation. For example, the total number of freight vehicles operating daily in the pilot area experienced an increase from 14 to 24 vehicles. But then, how does this baseline data help us understand the KPIs? Let's take a look at the next slide. In this slide, we look at how the dashboard transitions from raw baseline data to calculate key performance indicators. This slide specifically highlights the relationship between the comprehensive set of baseline data points and the corresponding KPIs, using KPI 9, CO2 emissions per parcel, as a concrete example. On the left side of the dashboard, we have a detailed table outlining numerous baseline data descriptions, each with its associated units. These data points represent the fundamental measurements collected from the Living Labs. For instance, we track the population of the city during the last year, total number of freight vehicles operating in the pilot area daily, and the weighted average of CO2 emissions per kilometer for all vehicles in the pilot area. Other crucial baseline data includes the number of cargo bikes operating daily, the percentage of successful deliveries on the first attempt, and average moving minutes per vehicle per hour. Furthermore, the dashboard collects data on the infrastructure, such as total available square meters of shared space for underutilized transport infrastructure and average cost per parcel. Data related to digital integration is also captured, like total minutes while sensors were not working properly, and the number of different data sources added on City's data aggregation platform. This extensive array of baseline data provides the granular details necessary for deep analysis. This baseline data then feeds into the calculation of our key performance indicators, which are shown on the right side. The dashboard automatically processes the baseline information to drive these KPIs. For example, baseline data concerning CO2 emissions per kilometer, total number of vehicles operating in the pilot area daily, average number of deliveries, and the number of parcels are utilized to calculate our highlighted KPI 9, CO2 emissions per parcel. Other important KPIs derived from this baseline include traffic flow, distance traveled, electric vehicle adoption rate, and cargo bike deliveries. We also track operational aspects like delivery time and cost per parcel, alongside indicators for infrastructure utilization like space utilization efficiency and micro capacity utilization. The dashboard strength lies in these predefined formulas, such as the one implicitly shown as baseline data DISCO curve D4 times baseline data DISCO curve D3, divided by baseline data DISCO curve D5 times baseline data DISCO curve D6, which links specific baseline data cells to the automated calculation of each KPI. This structured approach ensures a clear, transparent, and accurate transformation of raw data into actionable performance metrics. On slide 8, we have the aspects of the dashboard in the clustering and weighting of KPIs, which are essential inputs for determining the overall KPI value. KPIs are not treated equally. They are categorized into different clusters based on their relative importance from the perspective of the Living Labs. In this slide, we show an example of what clustering and ranking might look like for a Living Lab. Cluster 8, which is very important, Cluster B, important, Cluster C, which is less important, and Cluster D, not applicable. Cluster D contains KPIs that for specific analysis may not be relevant, for example, delivery density or cost per parcel. Each cluster is assigned a specific point value. Cluster A receives 3 points, Cluster B receives 2 points, Cluster C receives 1 point, and Cluster D is assigned 0 points. On slide 9, we can show the power of when the dashboard truly comes alive in the automatic calculation of KPIs. The dynamic nature of the system means that any change in the baseline data immediately and automatically reflects in the KPI values. The weighting mechanism plays a crucial role here, as it normalizes the changes in the KPIs, making them comparable and interpretable. Let's illustrate this with an example from the Helsinki data. As you can see, the electric vehicle adoption rate showed remarkable progress, moving from 4.4 average vehicles per day to an average of 18 vehicles per day, an increase of 309%. With a positive weight of 3, this is a strong KPI value of 6, indicating a good outcome. The dashboard excels at enabling in-depth analysis of KPI values and their changes. The visual representation in the graph clearly shows the Helsinki KPI 2024 versus Helsinki KPI 2025 for various indicators. For instance, we can observe the increase in cargo bike adoption rates from 0 to 3, or the significant reduction to CO2 emissions per kilometer from 0.28 to 0. The direct comparison allows for immediate identification of areas of improvement or concern. One of the most impactful features in the visualization of KPI changes, particularly when filtered by impact domains and specific measures like DISCO-X, the bar chart powerfully displays the Helsinki KPI 2024 values, weight value, changes in percentage of KPI, Helsinki KPI 2025 values, and the calculated value of KPI. This multi-layered view offers a holistic perspective on performance. This filtering can be done on several other measures and categories. In conclusion, the DISCO dashboard stands as an indispensable tool designed to extract quantitative findings from the Living Labs, drawing upon a vast array of collected data. Its meticulously developed structure and robust functionalities empower users to adopt and carry out analysis from various perspectives and categorizations, ensuring comprehensive insights. Beyond its primary role in data analysis and preparation, the dashboard is also a highly effective instrument for continuous monitoring and optimization of implemented measures over extended periods, fostering ongoing improvement in urban logistics. Thank you for your attention and engagement today. I hope the presentation has provided a clear understanding of the capabilities and value of the DISCO dashboard.